What's up? It's your old pal, Mr. Cook. We're going to do number 8 and number 9. A ball is thrown with an initial velocity of 70 feet per second at an angle of 40 with the horizontal. Write the velocity vector v in component form. Okay, let's see here. So this is just from initial velocity of 70. So 70 feet per second is going to represent the magnitude in this case. And then the angle of 40 degrees, that's going to be the direction. So if it's asking us to write down v in component form, we just have to, use the same process that we did for these guys right over here. When we have the magnitude and the direction, and we need to write down the vector. Oh wait, isn't that these ones? Yeah, that's these ones. My bad. When we have the magnitude and the direction, and we need to write down the vector. So it's the same process that we did for number 6. So the velocity vector v is equal to the magnitude 70 times the cosine of the angle, between the angle of the direction of the vector, and then times 70, and then 70 times the sine of 40 degrees. All right, and then, just type it in your calculator, probably like rounded to a couple of, 3 decimal values or whatever. So let's see what we got. So I'll do the first one, 70 cosine 40. So 53.623. I guess you should probably put feet per second. And then, do the other one, feet per second, round to 3 decimal places. Okay, let's see if this one's tough. An airplane's velocity with respect to air. Wait, with respect to the air? Oh, okay. The velocity with respect to the air is 580 miles per hour, and it is heading in the direction of, I hate this notation, north 60 degrees west. So I think that means like if I'm going north, it's 60 degrees west of that. So it's like over here by 60 degrees. Okay, so like here's the vector right here. I'll color it in red. This is my velocity vector right here. Okay. And it looks like it's going 580 miles per hour. All right, there's the horizontal, by the way. All right, at the altitude of, the wind at the altitude of the plane is blowing at a speed of 60 miles per hour in the direction of north 45 degrees east. Okay, so that means that so from the velocity vector, here's now the wind vector. Okay, so if here's where the plane is, at this end point. Now here's north, and then we got to go 45 degrees east. So east is. Oh wait, did I mess it up? I wrote 60 degrees west. Darn it! I went east instead. I messed it up. I'm sorry about that. So. Maybe just forget what I just said for a second. I messed up the direction here. So if it's going north, okay, so here's north. West is this direction. Come on, Mr. Cook, you know that. And then if it goes 60 degrees west from north, then it's, where's my pad? There it is. Okay. So it's like 60 degrees this way, okay? So here's the direction of the airplane. 60 degrees west of north. And it's going at 580 miles per hour. There we go. Yeah, that's a little better. Yeah, okay. And then now the wind is blowing a little bit east of north. So imagine that the airplane is here. Here's the northern direction like that. And east is to the right of that. So it's east is this direction here. So the wind is blowing in this direction. It's going 45 degrees east of north. So over here. And it looks like its velocity is going to be 60 miles per hour, like that. All right, so let's see. Draw a diagram to represent the problem. There we go. That's how that goes. And then, what is the true direction of the plane, and what is its ground speed? So let's see here. The true direction of the speed is going to be finding. It looks like just the sum of these two. Yeah, that's it. So the direction is just going to be from here to here. So you just got to find that, the sum of it. And what is its ground speed? So its ground speed is going to be the magnitude. So we're looking for the angle between them, and then also the ground speed, which is the magnitude of the sum of these two. So like the speed of the plane or velocity of the plane plus the velocity of the wind. Okay. And then the direction is going to be, I guess it's just going to be like the theta that we get from, these two. So we're going to use that formula that we just previously used in 7D, cosine inverse of, what was it? It was, oh, I have it up there. The dot product of the two of them over the magnitude multiplied together. Okay. So there we go. We just got to plug that in, and then and I should probably change up the letters. Darn it. Sorry about that. So it's the velocity of the plane, V, and W, dot product. That's the wind's velocity. There we go. Okay. So let's see here. And some of this is pretty nice already. The airplane's velocity with respect to air is 580 miles per hour. That's just its magnitude. And I think that it means I think it means with respect to the ground, not like with respect to the air. I'm not 100% sure about that, but it seems like that's what the wording really means. So yeah, so let's go through this. Sorry, I don't mean to sound so confusing about all this stuff, but so we have, let's see, cosine inverse of, and then let's write down the stuff that we have. The velocity of the plane, that's 580, so that's going to go down here, 580. Velocity of the wind, that was 60 miles per hour, so that's going to go down here. And then the dot product. So the dot product is going to be a little bit weird because we need to write down the components for these things. And to do that, we need to figure out the angle measurement that we get from each of these right over here. Okay. All right. So let's get the components for V and the components for W. So V, the vector, looks like this so far. It's let's see, the magnitude, which is 580 times the cosine of, the angle measurement. Let's figure out what the angle measurement is of the airplane, which is the red vector. So if this is 0 degrees here and we're going like that, then it's going to be 90 and then an additional 60 degrees, so 150 degrees. And let's finish writing the rest of it. So the x component is 580 cosine, so then the y component is going to be 580 times the sine. And then my w, my wind vector, let's see how that one's going to look. So let's see here. So if it was 45 degrees, I think it's just going to be, it's still just going to be 45 degrees. That from east, from 0 degrees. So we're gonna have 45 degrees here, both of those. But the magnitude for the wind is 60 instead. So 60 cosine of 45 and 60 sine of 45. Okay. So now we can do the dot product. This is where you just use your calculator essentially. So let's do that. So we've got to do this one times this one, and then plus this one times this one. Okay. So let's type those in. 580 times the cosine of 150. I'm through using my unit circle. Well, gosh, should I use the unit circle? No. I'm not going to. I'm just gonna multiply them together. So then times 60 cosine of 45, and then plus, and it's going to be 580 sine of 150 times 60 sine of 45. All right, here's my dot product. Oh boy, that's a big number. Cosine inverse of that can't be right, because that would be a huge, Well, no, actually, it might be okay. Let's see. So we do cosine inverse of that number we just got divided by parentheses 580 times 60. Do we get a number? Yeah, we do. Whoa, just 105 degrees. That's pretty cool. So 105 degrees. That was interesting. So I did like the dot product. What did we get again for that? 9,006.903. Negative 9,006 point, what was it? 903. Okay, there you go. So that's the angle between them. That's the direction of the plane. So that's like relative to east. Do we have to write that up as like a thing? I don't know. We might have to. So let's see here. So north is 90 degrees. If this goes 105 degrees, then that means that it would go like, let's see, what's the remainder of that? So it's 90, that'd be 15. So here's like the direction. It would be, oh God, north 15 degrees west, right? Because like there's west right there. Gosh, that's how we'd probably have to write it up. That's pretty obnoxious. Okay, there you go. So there's the direction of the whole stupid thing. And then what's its ground speed? So its ground speed is going to be the magnitude of the sum of these two. So that's going to be a little bit of work too. My goodness, I really bit off a lot for this number 9, but whatever. It is what it is. Okay, so let's add the vectors together first, and then we'll do their magnitude on our calculator. So let's see here. V plus W is 580 cosine 150 plus 60 cosine 45. And then the y component is 50 or 580 sine of 150 plus 60 sine of 45. All right, now we do the magnitude of this thing. So this is v plus w, so the velocity of the plane plus the wind's velocity. And now we do the magnitude of this thing. So, as you'd probably guess, we're just going to take whatever those numbers are and do like the Pythagorean theorem kind of thing for them. So let's say that this is like the x component of it, and this is like the y component of it. What we're going to do is take the square root of x squared plus y squared. So we're going to use our calculator big time for this thing. All right, let's type it in. So we've got square root of, and then it's going to be parentheses 580 cosine 150 plus 60 cosine 45. Okay, and then that quantity squared plus parentheses, and then it's going to be 580 sine of 150 plus 60 sine 45 squared, so that quantity squared as well. And then we do our calculator, and that's what we get, 567, and I think it was miles per hour, right? Is that the units that we had on there? Yeah. So let's say about 567 point, what was it again? 438. And then miles per hour. All right, there you go. There's the ground speed, and then also the also known as the magnitude, and then also the direction. We calculated that a little earlier. Wow, that was a lot of work for number 9. Okay, well, whatever. That's the end of this worksheet. So I hope that you learned something. And if you have questions, make sure to reach out to your teacher. All right, bye-bye. Thanks for watching.